Okay, students. So you all are almost towards the end of your 12th standard. You will be writing your entrance exams. Those of you who are appearing for the JEE mains will be writing your exam in like exactly another 52 days or 50 days. Those of you who are preparing for the NEET have much more time, and you will be writing your exam in the month of May. Okay. So now I will just brief you or tell you how to use this particular program that we are doing. Now you will be given two question papers on each chapter. Okay. So try to work out those two question papers within a 1 hour time slot. Now both the question papers will be discussed with you, and the formulas and the different concepts which are required will be discussed when we discuss the solution. So just go through the solution. When you are going through the solution, you don't have to go through it slowly for each question. Identify where you are making mistakes and then try to look at the solution for that particular thing. Now, before we do every chapter, I'll also try to send you a small video which will give you a recap of that particular chapter. So have a look at the recap, start answering the questions, make a note of the different concepts which are there, and remember to follow the NCERT. All your questions 100% will come from the NCERT. As I keep working them out, I'll tell you different techniques that could be used to simplify calculation or increase your speed of calculation. Then the first one or two chapters are very simple chapters, so there won't be any big theory there or any big value addition there. But I am sure from the time you start with forces and Newton's laws, you will see a huge value addition as far as these discussions are concerned. Okay, then we have kept the question simple in mind so that the basic concepts are revised. So if you just go through it, I think it should be enough. Okay, now let me just take a little time and explain to you the different concepts which are there in this particular chapter. So we are talking about units, dimensions and errors. Students, in this I can think of these four categories from where your questions can come. Whatever question you comes in the exam can be classified into in one of these four categories. So you can have questions based on dimensions. As you keep working out, you will see. Then there are questions based on significant figures and scientific notation. Then there are questions based on errors. In errors, you have this absolute error, relative error. They could ask you questions on that. They could ask you questions when you are multiplying and dividing quantities, error when you are adding and subtracting quantities. Apart from this, they can also ask you questions on random errors and systematic errors. So again, you should know what random errors and systematic errors are. Then they can ask you questions based on vernier calipers and screw gauge. Okay, so what I'll do is I'll take a few minutes and try to explain to you the different types of questions and how to work them out. So dimensions, I think, is clear, you will be able to do. One specific type of question where I have a lot of difficulty, I'll explain. Say for example, the dimensions of force is given to you, mLt power minus 2. Now the question is, the unit of mass is doubled, then the unit of time or length is maybe made 1/3, and then the unit of time is again made half. Then what will be the suppose I have 20 newtons, what will be the value of 20 newtons in the new unit, or what would happen to a given measurement in the new unit? So these kind of questions are a little tough because I have not told you what exactly doubled means. Okay, now mass is doubled, or the unit of mass is doubled could mean two things. One, already I am measuring here in kg, so instead of 1 kg I am making 1 kg equal to 2 kg. So if I am making 1 kg equal to 2 kg, then it will increase by a factor 2. Similarly, if the length is made 1/3, then the length value will decrease by 1/3. Similarly, because it is to the power minus 2, it will become 4 times. So into 4 times. So by this logic, this would become 8 by 3 times the old measurement. So whatever old measurement you have, that will increase by 8 by 3. I can also mean one more thing. Right now, I am measuring 1 kg. So if I am measuring 1 kg, in the new system, the unit is not 1 kg but 2 kg. So here if I have 10 grams, 10 kilograms, in the new unit, how many will I have? I'll have 10 by 2, I won't have 20. Okay, so here you have to be very particular about the English. I have seen this question at many places. I feel that they are not explaining enough, or they have not given the question clearly. In most places they mean this. That is why I have taken this. But if they say that the unit of mass is doubled, what does it mean? Right now the unit is 1 kg. You are making 1 kg 2 kg. So if you are making the unit of mass 2 kg, then the old measurement that you did of 10 kg now will not be 10 kg, it will become 5. Okay, so there is a difference there. So please read the wordings properly so that you know whether they are meaning this or whether they are meaning that. Other than that, you will not have any issues here. Make sure that you know the units of coefficient of viscosity, epsilon naught, mu naught. Most of the questions that come around this. Okay, so please make sure that you understand that. I am ignoring dimensions. Dimensions is easy. But in case you want a better explanation on dimensions, please message. If you put a message, we will be able to send you some videos with respect to dimensions. Okay. Now, the next one is significant figure digits and scientific notation. I hope you all remember significant digits. So, suppose I have 3.0. Now, this 0 is not significant. Any 0 after the decimal, if there are no digits, is not significant. Now, if I have 0.30, now this 0 is not significant, but this 0 is significant because it has a digit preceding it before the decimal. So there is a decimal 3, this 0 is significant. Okay, so zeros are insignificant when they are before the number. So if I write it as 303, 030, all these are insignificant. All these zeros are insignificant, and there are only one significant figure in each. But a 0 between two significant figures is significant. So this is significant. So now there are 3 significant figures. Similarly, if you have 3.003, now there are 4 significant figures. If you have 3.0030, now this 0 after the decimal at the end of the number is significant. So now here there are 1, 2, 3, 4, 5 significant figures. Okay, so please understand this. Also remember, whenever you change unit from kilogram to gram, or any unit from one unit to one form to another form, there is no change in the number of significant figures. Number of significant figures is independent of the units which you use to explain. Okay, so remember that. Then scientific notation. Scientific notation is simple. In scientific notation, everything is expressed to a units place. That means if you have 3004, it is written as 3.004 into 10 power 3. If you have 0.002, you write it as 2 into 10 power minus 3. So this is scientific notation. In scientific notation, everything is expressed to a units into 10 power whatever. Okay, so this is how you get the scientific notation. Then sometimes when you have this, you may have to round off. So there are several questions which are based on rounding off. So I'll just explain to you. So if you have 1.43, you have no doubt you will round it off to 1.4. But if you have 1.45, how will you round it? So now you look at this number. If this number is an even number, you just drop the 5. If this number is an odd number, then you take it to the next number. Okay, so 1.25 is rounded off to 1.2. 1.75 is rounded off to 1.8. So I hope you understand this. Okay, so when you have 5, that is when the difficulty comes. Then you look at the preceding number. If the preceding number is even, you drop the 5. If the preceding number is odd, then you go to the next one. These errors, absolute, relative, you should know. Absolute error is the actual error that you make in measurement. Okay, and the minimum actual error that you would make in the measurement is the least count of the device. So if I am using a simple scale, the minimum error will be 1 millimeter. If I am using a second swatch, the minimum error will be 1 second. Okay, so absolute error is the actual error that you are making in any measurement. Relative error is the error divided by the measurement into 100. So suppose I have measured 5 centimeters using a meter scale. So if I am using 5 centimeters, if I am measuring 5 centimeters using a meter scale, the error as per the logic that I told you just now is 0.1. So 0.1 divided by 5 into 100. So that will be 10 by 5. So 10 by 5 will be 2%. So the error will be 2%. Okay, so that is how you treat absolute error, relative error. Maybe I'll just explain it little better. Relative error is equal to absolute error divided by measured quantity into 100. absolute error by measured quantity into 100. Suppose you are measuring 20 seconds. Suppose your measurement is 20 seconds. The least count is 1 second. So the error is 1 by 20 into 100. So this will become equal to 5%. This is the least count of the instrument. The minimum error that you would make is the least count of the instrument. Okay. Now sometimes they are asking you questions like this. Suppose I am measuring 20 oscillations of a pendulum, and the 20 oscillations, the time measured is 40, 41, 42, 44, and let's say 38. And they are asking you what is the percentage error in this, or what is the error, absolute error and percent error. So the way you go ahead is first find out what is the measured quantity. So for 20 oscillations in 1, 2, 3, 4, 5 readings, I have measured this. So let me find the average. To find the average, don't add all the numbers. Just assume one number is the average. So from here you see how much is the deviation. This is minus 3, minus 1, this is 0, this is 1, and this is 3. So these two will cut off. So 41 is the average. Now you find out what is the error. Now to find out the error, we find out the average error. Now we don't bother about the negative sign. So the average error is 6 by 5, that will be 1.2. Now look, here you have one decimal, but here there are no decimals. So this has to be rounded off. So this has to be rounded off to 1. So in this case the average is 41 and the error is 1. Now if you want to know what is the percentage error, it will be 1 by 41 into 100. So this will be close to 2.5. So the answer is 2.5%. I have done this calculation and based on that I am saying. So it will be 2.5%. So the error for this is 1 second, the average for this is 41, and the relative error is going to be 2.5%. Okay. These kind of questions are very popular, more so in the JEE mains than in the NEET exam. Okay, so I hope this aspect is clear. Whenever you are multiplying and dividing quantities, the relative errors are added, that is the percentage errors are added. Whenever you are performing addition or subtraction, it is only the relative errors, it's only the absolute errors which are added. During this time the absolute errors added, so I will write it neatly for you. In division and multiplication, relative errors are added. In addition or subtraction, absolute errors are added. Okay, so I hope you understand the difference between these two. Okay, now suppose measurement of a quantity A, the error is 2%. In measurement of A square, it will become 2 plus 2, that is 4%. In measurement of A power half, the error will become 2 by 2, it will become 1. So I hope this aspect you know. Then in measuring A power minus 2, now it won't become minus 2 into 2. Errors will never be negative. Errors will always be positive and they have to be added. So even in A power minus 2, the error is 4%. Okay, so I hope you are able to understand. The next thing that you would want to know is about the least count of vernier caliper. The least count of a vernier caliper is equal to one main scale division, that is the length of one main scale division minus the length of one vernier scale division. Okay, so now in the main scale, suppose 1 centimeter is divided into 10 parts, then one main scale division is 1 mm, or which is equal to 0.1 cm. Now they will tell you that 9 divisions of main scale coincide with 10 divisions of vernier scale. Then the error 1, so 10 divisions, so 1 division will become equal to 9 by 10, but 1 division is 0.1. So the answer will be 0.1 minus 9 by 10 into 0.1. So that will become equal to 0.01 mm. Okay, I will demonstrate it by using another example. Suppose 9 divisions coincide with, let's say, 20 divisions on the vernier caliper, and 1 centimeter is divided into 10 parts on the main scale. So, one main scale division is 0.1 centimeter. One vernier scale, see, 20 divisions are equal to 9. That means 20 divisions are equal to 9 mm. So, one division will be equal to 9 by 20. 9 by 20 is decimal 0.45. So, 0.45 mm. So, the least count will be 0.1 cm minus 0.045 cm, or it will be 1 mm minus 0.45 mm. So, that is equal to 0.55 mm or 0.055 centimeter. So, this is going to be the least count. Okay. Similarly, in a screw gauge, you have a circular reading, or on the screw, if there are 100 divisions and you rotate the screw. When you rotate the screw, you will be moving on the main scale. Suppose you move 2 units on the main scale, that is 2 millimeters on the main scale. So, what does it mean? When you move by 100 divisions, the measurement is 2 mm. So, when you move by 1 division, the measurement is 2 by 100, that is 0.02 mm. So, remember that the screw gauge will have a much lower least count than a vernier caliper. A screw gauge is a more accurate instrument than a vernier caliper, and this is how you calculate the least count. Least count is equal to pitch divided by number of divisions on circular scale. This is the least count of a screw gauge. That is the least count of a vernier caliper. Make sure that you understand these two. As far as NEET goes, the questions won't go beyond this. In the JEE mains, there could be questions on zero error. Zero error, remember, zero error is always subtracted. There are two kinds of zero error. There is a positive zero error and there is a negative zero error. Positive zero error means what? See, you have to see a vernier caliper. If you have a vernier caliper, there will be two jaws. So, when the two jaws are together, the zero of the vernier should coincide with the zero of the main scale. But in reality, that may not happen. So, they should coincide. When they coincide, there is no zero error. Sometimes what happens is the zero of the vernier is on this side. So, this is the vernier scale, this is the main scale. If the zero of the vernier is on this side, this is a positive zero error. Positive zero error means my reading should have been 0, but it is already showing something. And remember, positive zero error is always subtracted. On the other hand, if this is the main scale 0, the vernier scale 0 is here, then you have to move to here and then start. That means this is already not being counted. So, that is a negative zero error, and negative zero error is always added. So, remember these two things. Okay. So, very briefly, these are the concepts in this particular chapter. As you keep moving, the concepts get more difficult. I will explain to them in more detail. Even now, if you think you have any specific question, please drop in a message in the chat box. I will create a small video explaining that particular aspect and then send. Okay. Remember, your success is yours. For your success, you have to work. We can only help you. So, if you think you need any help, please drop in a message. We will try our best to help you. Thank you.